Yeah, hi, thanks for attending. My name is Adina. I'm from the Jülich Research Center in Germany, where I'm in the Institute of Neuroscience and Medicine by Simon Eickhoff. And I'm here because I'm a Repronym Fellow, a teaching fellow. So I've been teaching about reproducible practices for neuroimaging for the past year. I'm joined by Jarek. Do you want to introduce yourself?
Hi, I'm Yarik. I'm research associate professor, so I'm not teaching, and that's why it's better for you that I surrendered the stage to Adina, who will do this job much better. And I'm from Dartmouth College, as the title says.
Yeah, Jarek is going to be a little bit of a sidekick for me. I'm going to be focusing on sharing slides and live coding, and Jarek will answer questions that you have, either if you paste them in the chat or if you paste them in the Etherpad. Okay, so without further ado, I will start and talk a little bit about DataLad and how this software can help you with data management. As a quick intro on how the session is going to work, it's going to be a mix between live coding and an optional hands-on that you can join in order to code along with the same code that I'm executing. I will demonstrate a couple of workflows. I won't be getting into too many details, but you can find out everything that you need to copy and paste, and also much more instructions and details and further references if you want to find out more under this link. I will quickly click on this link and show you where this leads you to. This is a page in a document that is called the Datalet Handbook. And if something that I'm talking about today intrigues you particularly, this is also the resource that I would advise you to go to in order to learn anything about DataLad that you would want to dive deep into. In this section here, you can find these code snippets that you can just copy and paste into your own terminal in order to follow what I'm doing. Alrighty, so before I get into the live coding, I will give a very brief introduction to try to give you a glimpse of what DataLad is. And until I'm done with that brief glimpse, you have the chance to take care of the software requirements that would be needed if you want to do the hands-on session with me. And if you haven't installed DataLad yet, then you have still 5 minutes of time in order to do this. You can find installation instructions also at handbook.datalet.org. You will need a container software that can be Singularity or Docker. And I provide commands for both of these container solutions in the code snippets. And you will need to install what is called Datalet extension, which is a Python package, Datalet containers, and this is available via pip, for example. So to give you a brief overview of what DataLad is, it is on a user-facing level a command line tool. That means that you're using it in a terminal, just like the one that I'm screen sharing on the right-hand side. And it is available for all major operating systems. So regardless of what computer you're having in front of you, you should be able to follow along, install DataLad, and use it. It's open source software, of course, and it is built on top of two very nice, scalable and established tools, which are Git and Git Annex. I'm not sure how familiar you are with these tools. If not, it's not a problem at all. The only thing that I want to mention about them is that they are version control tools. And the fact that they are version control tools leads me to one of the many features, or one of the major features that DataLad has, which is version control for arbitrarily large files. This means that when you use DataLad, you can perform version control, which is tracking of changes done to files over time for anything that you're working on. That may be your code, but that means also that you could version control your data and your software in the form of software containers alongside to your code. If you're used to using Git, then this is something that you wouldn't be able to do with Git. Another major feature of DataLad is transport, because it makes sharing and collaborating and consuming data very easy and streamlined. In a way, you can install data as easy as you can install software with package management systems, and you can publish data equally easily with the available infrastructure that you use anyway. But if that is GitHub, if that is the Open Science Framework, Google Drive, or something similar. And another major feature that DataLad provides is computationally reproducible data analysis functions. Because DataLad is not only able to version control everything that is involved in your data analysis, but it also providing functions to assist you in running your analysis, capturing process provenance about this analysis, and having an analysis automatically redone and verified to be identical to a previous run of an analysis. Importantly, DataLad is a completely domain agnostic tool. So if you ended up here not being a neuroscientist, but maybe a physicist or someone else, then DataLad can still be useful for you, although the examples that I will be using today are tuned to neuroimaging. I want to give you a couple of examples to show you what DataLad can be used for, or what many people use it for. One thing where it is incredibly handy is that it makes it very easy to publish or consume datasets via very open infrastructure that is accessible to many people, such as GitHub, GitLab, the Open Science Framework, or similar services. Here is a screenshot of me cloning the Human Connectome Open Access dataset from GitHub. It is as easy as running a single command, Datalet clone, and then running a second command to get access to all of the data in the Human Connectome project on a single file basis on demand. This has two advantages. For one, it's really fast to get access, actionable access to the Human Connectome project. As I will show you later, this access is really tiny in disk usage. It is also fantastic that I have very fine-grained access on which file I actually want to obtain from these huge data releases. The next example of what DataLad can be used for is something that is not actually visible for you, but that I still like to include, because even if you have never used or heard of DataLad, it's quite likely that you have used a tool that is actually using it as a backend. So services like OpenNeuro or BrainLive or CONP or CBrain use it as a backend to perform some of the operations they do in the background. So if you would go to OpenNeuro and search for any dataset, then these datasets that you can find there, they are transport logistically managed in the background by DataLad. And for any dataset that you will find on OpenNeuro, there actually is an associated DataLad command that will retrieve you the data in the same way as the previous screenshot has shown. And if you've ever analyzed anything on OpenNeuro, then the way that datasets are getting into the analysis framework there is also managed via DataLad. Another great thing that DataLad is used for is to create and share reproducible and open science in however that may look in your specific case. You can share data, you can share software, you can share your code, and you can share computational provenance of what you have done. Here, for example, is a paper of mine where I am able to share code, data, and a computationally executable manuscript in the form of a GitHub repository. And cloning this GitHub repository gives any reader, without even needing to have a GitHub account, the possibility to get my manuscript, get all of the relevant data, and recompute my results from scratch. Here's another example that just came out a week ago, which is really fantastic use, in my opinion. This is a tweet of a recently published paper, and it is accompanied by a fantastic supplementary material where the authors have just generated a bookdown document where they not only share their code, but also their data, 1.5 terabytes that is published and version controlled with DataLad, and where they render their results on the fly, actually via continuous integration. If those are concepts that you're familiar with, then I hope that you're as excited as me about them. If not, you can read on in the handbook about these things if you want to learn more. And as a final thing that we use Datalet for, and that may be of interest for anyone who ever needs to write a data management plan, for example. We use Datalet in our institute as a central data management and archival system. So here's a screenshot of our institute's GitLab instance. And in there we have a repository that is called Dataset that hosts all of the datasets that we in our institute work with. And just like in the previous examples, I can go into our cluster and clone this repository. And after cloning this repository from our GitLab instance, I have access to all of the raw data, all of the process data, and all of the archive data that our institute provides, and where I have signed the respective data usage agreements, if there are any for those datasets in place. Cool. So unless there are any questions, if so, please speak up and ask me. I will continue with the live coding session. And for this, I'm just going to reiterate the prerequisites that are necessary if you want to follow along. One, you should have a recent DataLad version. I can run the DataLad -version command to find out which version of DataLad I'm running. And in my case, it is a very recent version of DataLad. I should also make sure to have what is called a Git Identity configured. A Git Identity is making myself known to the version control tools that track a range of basic provenance about the things that have been done over the course of, for example, a data analysis. In the case of this configuration, it is a name and an email address. And this information is used to associate changes that you do over time with your name and identity. So I've just shown you how these configurations can be applied. If you are following along, you can find commands to check whether everything has worked out correctly for you. Okay. Now, if you're using DataLad on a day-to-day basis, there are several means to do this that I want to mention before I go into the terminal, because in the terminal, while the probably most often used way of using DataLad, there are also other means. It has a Python API, it is Python software, so anything that I'm doing in the terminal, I can also do in a script. And I can also use external software. It doesn't need to be Python, for example, MATLAB or R, where I can just use system calls to use DataLad. Cool. So anything that we're doing in this code along session and anything that we're doing with DataLad happens in what is called a DataLad dataset. This is DataLad's core data structure. And it is nothing but a directory where you instruct the software tool DataLad to manage it. And any directory in principle on your computer can be managed by DataLad. You can create new datasets from scratch or install them from local paths or URLs or other places, and I will show you these later. You can also link them or nest them, and I will get into the details of that soon. And on a technical level, a DataLad dataset is a joint Git Annex repository. I'm just going to create a dataset now to show you how this is done. So what I'm running here is the DataLad create command. This command doesn't need much. In principle, it only needs a name. In this case, the name is bits data. And if I run this command, it will create a new directory called bits data on my file system. So if I execute this command, it has created this new directory for me. You will notice that I have supplied an additional command argument here, the -c option, and supplied the word text to git to it. a little bit of technical background on this is given later, but what this is a configuration, and this configuration applies a very useful set of rules to my directory that makes it very easy to work with files of varying types in the version control features of Datalet. And I hope that I can get to the details of that in a few minutes. So at this point, I just have an empty directory on my computer. And this directory I can now use to, for example, perform a computationally reproducible analysis, version control data, or collaborate with others. I'm going to very briefly demonstrate the version control features of Datalet in a very simplified example. So this directory is currently empty. One thing that I want to use this directory for is creating a bits dataset. And for this, it is useful to have a human readable description of what I'm doing in here. So I'm creating a simple markdown README file. Let's create such a file by simply echoing a header for this file into a new file, readme.md. What has been done on a technical level is now that something in this directory managed by Datalet has changed, because everything in there can be version controlled should you want to. You can detect the change that has been done with the version control tools. So if I run the command datalet status, it will report on the current state of the dataset. And as I have placed a new file into this dataset, it will show up as being an untracked file that is not yet known to the version control systems. If I, as a user, now decide this is a modification, a change to my dataset that I'm fond of, that I want to keep and version control, then I can save this modification, and in this case, it is this untracked file, with the datalet save command. If you are familiar with Git, then you will know the concept of attaching a short description to the change that you are doing. And this is done here with the -m, which is short for -- message option, which just summarizes what I have done in a short human readable message. And I will show you where this shows up later and how it is very helpful to do this in a nice and human readable way. Now, Datalet Save has added the README in its current state to its dataset, to this dataset. And I have now version controlled this. So if you are a Git user, then you will notice that this is a version control mechanism that is simpler than what Git uses. It doesn't have the staging area, which is where the file is placed when you would run a git add before your git commit, but it's actually combined. So this way, version control gets a little bit easier, especially if you haven't used version control tools much. Let me show you, or let me extend this very simplified example a bit by modifying this version controlled file. I'm just going to add another line of text into my README. In this case, I'm just describing the data that I'm going to place into this dataset a little bit more. In this case, I'm just echoing the string contains functional data of one subject who underwent a localizer task into this README. If I query the state of the dataset at this point, then this file will show up as being different from the last state that it was saved in. So in this case, datalet status will not show that the file is untracked. It will show up as being modified. I can actually even be more precise and use any of the underlying tools, Git or Git Annex. And in this case, I can use, for example, the git command git diff to get even more precise information on what exactly the change is that has been done to this file. If I'm fond of this modification, then I can also, again, do a datalet save to save this modification in my dataset with a nice and human readable commit message. Cool. So what this tried to showcase in a very simplistic example is that Datalet basically just knows two things: datasets and files. We're in a dataset, bits data, And any file that is placed into this dataset can be version controlled. So I have created a new dataset. I have placed a modification in it in form of a new file or in the form of modifying an existing file in there. And then I can use the datalet save command in order to save these modifications in my dataset. This makes version control, which is an incredibly powerful feature, incredibly easy. It's a modification followed by a datalet save. One thing that you should keep in mind when you're using this is that datalet save will save any change that you place in your dataset at once. You can give more precision to that by, for example, just specifying the file or modification that you want to save as a path next to the datalet save command. So for a very clean and nicely structured dataset history that you're building up, it is advised to save meaningful units of change. That means only changes that belong to one entity or unity, and to attach helpful commit message to them. And I'm going to show you where these commit messages really end up being helpful. If I query the dataset history, which is where all of the modifications are tracked together with some provenance information, I can query this with tools that can visualize what is called Git History, and one built-in command to do this is Git. Then I can see, and this may look unfamiliar for people that are not using version control tools, I can see a history of everything that has been done. And these two entries right here are the ones that I have just done to the dataset. They are organized such that the most recent one is at the top and older ones are at the bottom. You can see that I am named here as the author of a change, and there's also a date where things happened, and there is a description of the thing that I have done. Importantly, the modification that I've performed is not only identified with this commit message, but there's also this cryptic character sequence, which is called a commit hash or SHA-SUM. And this cryptic commit hash can uniquely identify anything that has been done. And I can use this representation of a change to, for example, reset or redo a specific modification. So now that you have a short intro on version control with Datalet, I want to mention the most important thing. Given that version control is so easy, and given that Datalet combines Git and Git Annex as version control tools, you have the ability to version control data, because you have you can add data of any size, and that could really be a terabyte or more, into the dataset and version control it with the datalet save command, and it's going to be fine and will work nicely. So your next neuroimaging study can be version controlled and tracked with DataLad. And for open science or for reproducible science or just science in general, this is helpful because your dataset can become a complete research log by the help of the version control history that you accumulate. It can capture everything that was done in the dataset, when it was done, by whom, and if you give it a nice commit message, also how and why. So here is a Git log of, for example, a collaborative study where we have written a data analysis and paper, and you can see how this thing evolved over time. And as I've mentioned, you can interact with this history, for example, reset the dataset, throw out changes, identify a precise version of the data that you're using, and so forth. So as a quick summary, Datalet creates an empty dataset, and there are configurations that are useful and helpful. A dataset builds up a history that tracks files and their modifications, and tools such as Git log or other tools such as Tick can help to visualize it. A datalet save records the dataset or file state to the history, and if you attach a commit message to summarize the change, then your future self will be thankful. There's a command that I haven't introduced yet, but I will later in this tutorial, which can help you to save web content and record its origin. And finally, Datalet status is a command that should be used frequently as it reports the current state of the dataset. And it is good practice that a dataset state is clean. That means no modifications and no unchecked files. So the next thing that I want to show you is how you can consume data with Datalet. If you won't use Datalet for anything else, use it for consuming data because it's fantastic. So I will quickly go out of this directory and perform a command that is Datalet clone. Datalet clone, you have seen it already in the screenshots that I've shared, is able to install a dataset from an external place, for example, a repository on GitHub. And you can see that I'm giving a GitHub URL to the study forest project to the Datalet clone command. If I execute this command, you see how incredibly fast this command executes, even though what it is conceptually doing is it is installing a neuroimaging dataset with 20 participants from a neuroimaging study. If I go inside of this dataset and list the current directory contents, then you can see that there are all of these subject directories and all of these files. Now, what is quite cool and quite interesting is that this dataset is incredibly tiny. So if I print the size of the current directory in human readable units, it's very, very tiny, only 18 megabytes. This is nothing like a neuroimaging study. And the reason why this is the case is that the files that you can see here listed aren't actually yet on your system with their contents. It's just that something that we refer to as file availability metadata is present that you can browse through, but the actual file contents can be retrieved on demand with specific commands. So in principle, Datalet gives you access to plenty of data, but at little disk usage costs. Here is the same thing that I've just done on the slides. And now I'm going to show you how to be able to retrieve the data from this dataset. And this is intuitively named Datalet get. And the Datalet get call can take any path to a directory, to a single file, or for example, also as I'm doing it here, it takes globs. So in this case here, where I have this little asterisk character in the file path, I'm retrieving all files from, or all runs of Nifty files of one subject in the task object categories from this dataset. And this is now going to take a little more time to download because now I'm actually retrieving the physical real file content of these files from wherever these data are actually stored. Now, you may be confused that I'm able to install large files from GitHub, but they aren't actually stored on GitHub. They actually live on a web server. It's just that the dataset is interfaced via GitHub for easier access. The important point is that I can run Datalet get and you can run Datalet get, and you don't need to worry where the data is actually stored. Datalet will take care of retrieving the file content that you specified for you without you having to worry about how to access those data actually. What is also cool is that with this feature, you can have access to more data than your computer has disk space. So here are some examples for some of the larger neuroimaging datasets. The eNKI dataset, which amounts to 1.5 up to 3 terabytes, I think. If you clone it and have a full, if you clone it without retrieving any data, it is only 1.5 gigabytes of space that you need to use while still having the access to the data. And if you do this for the Human Connectome project dataset, it's quite large with almost 50 gigabytes, but that's nothing compared to the 80 terabytes that this dataset is actually heavy. But what is even cooler is that if you don't need file content anymore, you can drop it. And this is done with the Datalet drop command that essentially frees up disk space of files that are tracked and have an external copy somewhere. So if I drop the fourth run of the subject, it will remove the file contents from my system. And if I then ever need them again, I can reobtain them using Datalet Get. And now it is downloading again. So what stays behind when files are dropped is this file availability metadata that allows you to reobtain your files on demand. And what we use this for are disk space aware computations, where we install input data that is a lightweight, very low demanding disk space usage link. We retrieve the precise data that we need. We compute the results. And then we drop the input data that is not necessary to be there with their physical content, but we preserve the actionable access to the data so that others know which data was used, so that we ourselves can reobtain it for recomputations, and so that others can reobtain it too. And if I would want to do this in a Python script, then I could start my script with a datalet get in this Python call, and I could end my script with a datalet drop, so that I really don't have to worry too much about exceeding my usage quota on an HPC system or something like that. Cool. So right now you have learned how to install data. And in order to prepare the next session with David Keeter, I would actually like to ask you to put your newly learned skills into use, because David is going to need the contents of one data set for his demonstration. And this data is available from Datalet's what is called super dataset, which is a collection of almost 250 terabytes of neuroimaging data that you can get access to on your computer by running datalet clone 3/. You can just do this and explore everything that there is in terms of data. But I would specifically ask you to install one dataset, which is the brown dataset from the ADHD 200 sample, and then retrieve all of the file contents inside of there. It's not going to be huge. It's less than 1.5 gigabytes in total. Cool. In the meantime, I'm going to continue with my session. And at this point, I'm just going to do a small detour into the technical explanations of how things work, because while you don't need to understand all of this, it can be very helpful to just have an intuition on how the software behaves and why it behaves the way it does. So I've mentioned Git and Git Annex multiple times in this session already, and those are the version control tools that DataLad builds up on. When you have a data set, then it essentially is split in two different parts. It has a Git part, which is the part that stores your dataset history, and it has a Git Annex part, which is responsible for storing large file contents. These two parts are behaving very different. Git stores everything that is placed inside of it with all shared copies. And Git Annex will place everything that is stored inside of it into something that is called an internal dataset annex, where it manages file access to, for example, other copies of your dataset on a per file basis that you have control over. So this is a place where you, for one, want to put files that are sensitive, that you wouldn't want to share with everyone, or files that are larger so that they don't use disk space on all of the shared copies that you may distribute. Importantly, on the technical level, whenever something is placed not into Git, but into Git Annex, Git knows a little bit about this file, which is its content identity. This is based on a hash that encodes the content's identity without being completely revealing of the content identity. And this is a built-in mechanism that ensures file integrity. If you commit a nifty image into your dataset and it is annexed, and this nifty image changes accidentally, then based on the changed content identity hash that is automatically generated, the version control tools will automatically find out that something has changed in your data, and the Datalet status will be able to report to you that a file that you've version controlled has changed its content and let you reset the change or save the change if you are content with it. What is also important just to keep in the back of your head is that there is a difference in user experience depending on what files are in Git or Git Annex, because these tools handle files differently. Anything that is annexed is stuff that will not be readily available on your computer when you clone it. And thus all of the files that I've just retrieved via Datalet Get are annexed contents where the transport is handled by Git Annex, and anything that would be available right away is handled by Git. Another important thing that I will not demonstrate in this session, but that you can read up on, is that Git stores files in a way that are very, very user-friendly. You can modify them right away. Git Annex protects content identity by write protecting them. So you have to do a little detour to actually be able to save a change to a file that is protected by Git Annex. But for example, the README file in my dataset, this is a file that is placed in Git. I can modify it very easily, and I don't have to worry thanks to the text to Git configuration, which places all of those frequently modified files, just code or other text files in Git, about worrying about Git or Git Annex, or the difference in them. And a final note is that you have complete control over what goes into Git versus what goes into Git Annex. You can use run procedures that you can read up on. You can use self-made configurations, or you can decide on a per Datalet save basis. But in general, it is advisable to place small files and files that frequently change into Git, and large files or sensitive files that you wouldn't want to accidentally be shared with others into Git Annex. The next thing that I'm going to talk about is dataset nesting, which is a cool concept that is very intuitive if you've if you think about it from a scientific perspective. And for this, I'm going to go back into the bits dataset. And what I'm going to do now is I'm going to clone another dataset, but I'm doing it this time inside of this existing dataset. What this is doing is placing a link to a different dataset into an existing dataset. And you can think of this as a dependency relationship where I'm defining a new dataset. In this case, it's a dataset with DICOM files to be linked to my bits dataset in a precisely versioned fashion. While this command runs, I'm going to talk about the graphic that is here, because this is the scientific benefit of handling datasets in such a nested way. You can see here a stereotypic data analysis that evolves from raw data to pre-processed data to an analysis that is then becoming a paper. And you can see that each of these steps in the evolution of a scientific output are their own datasets. This basically links all of these different evolutionary steps as separate dependencies to everything that relies on them. But importantly, it makes all of these individual steps installable as their own module and thus reusable in any kind of context with a simple Datalet clone. This has two advantages. For one, if you go really big, human connectome project size or something like that, you need this in order to scale. The other advantage is that it modularizes these research components. It's more transparent, it's easier to reuse, and it's easier to perform access management because you can do it on a per dataset level. For example, never share your raw data, but share your pre-processed data with your lab or the public. And it is possible to create a lightweight, actionable link to your input data or software environment. So when I nest a dataset into another dataset, then we talk about these hierarchy dependencies in what is called a super dataset and a subdataset. And the subdataset is what I've just installed now. I've installed it under the name inputs raw data, and its super dataset is the bits dataset. And the super dataset importantly stores only a couple of things about the subdataset, namely which version it is in with a precise commit hash that identifies this data uniquely. And it records where this data has come from with the URL that I have cloned from, so that others could reobtain and transparently see where I have retrieved these data from. Now, what I want to showcase in this bits dataset is a reproducible analysis. And for this, I want to use the container software that Dorota has talked about. In order to get access to a software container of my liking, I will install a second subdataset into my dataset. And this is a very useful repronym tool, which is a collection of software containers that is available via GitHub from the repronym organization, and the repository is called Containers. This repository hosts a number of really useful containers for neuroimaging. And I'm just going to show you the amount of containers that I now have flexible access to by listing them across dataset boundaries. So what you can see here is that each of these lines is one container, for example, these bits apps that I now have flexible access to use on my data, which is a really handy resource to have. And I can also, just to illustrate the point about subdatasets, query my bits dataset about the subdataset it has. And here you can see that I have the container dataset that basically includes my software, and I have the input data that is here, raw data for my input. So I have these two dependencies to software and raw data linked to my data analysis. Now, a quick summary of dataset consumption and nesting. You can use Datalet clone to install a dataset, and you can install it on their own or inside of another dataset. You can retrieve files via Datalet Get if you want to, because only small files and metadata about file availability are present locally after you've installed a dataset. And I haven't shown you that, but datasets preserve their history. So whatever you have seen in the Git log of your dataset will be shared if you share your dataset as well. The super dataset then records a version state of the subdataset. Now for reproducible analysis, because that is another major feature that I want to showcase here with Datalet. And for this, a very quick rundown. I'm just going to skip a very quick rundown on organizational principles, just for the sake of time. We can go back to that in the end if we want to, but I want to get through with the code. So one way that Datalet assists reproducible execution and provenance capture is with a command that is called Datalet run. It's a command that you can use to record the input data, the output that a particular execution produced, and the way that you invoke the command or script that has performed an analysis. Because we all know about the importance of software as computational provenance, and the tool software containers to capture this computational provenance in a shareable format. I'm going to skip showing you how Datalet run works, but I'm going to skip ahead and show you how a container version of this command works, which is Datalet containers run. Datalet containers run is a command that records everything about a containerized data analysis that I would need to have in order to re-execute this. So what you can see here is that I'm specifying Datalet containers run first with a human readable commit message. Then I'm providing the container that I want to use. In this case, it's ReproIn, which is another really useful repronym tool for converting diagrams to nifties and structuring them to bits, for example. I'm specifying the input that I'm using, and I'm specifying an output directory in order to have an idea or to have a record of the output that is produced. And then as the last thing, I'm including the command that the reproin container would need to execute for me. And in this case, this is a specification of the underlying tool inside of the container that performs the DICOM conversion. Too little time to go into the details of that, but what I'm invoking here is udconf for DICOM conversion. If I execute this command now, then Datalet will first make sure that all of the inputs that I need for my analysis are available, and if not, it will download them. So in this case, for example, you can see that it is only now actually obtaining the software container that I need for my analysis. Once it has obtained all of the components that I need, input and software, it will try to run the command inside of the container that I have specified. And it will record and save every output that is generated during the command execution. And all of that will be saved together with my human readable commit message and with a machine readable and importantly re-executable record of what I have done in my dataset history. Okay, so now we have retrieved everything that was relevant in order to run the command, all of the dependencies. And now the command is actually running, and it is converting the DICOMs that I have installed as a subdataset using the reproin convention to a bit structured dataset. And what you will see soon is the actual NiPipe workflow that is running underneath in this container, but it will probably take another 30 seconds in order to get there. Okay, we're almost done. Now that the command has run successfully, everything that there's left to do for Datalet is saving all of the modifications that have been produced here. And now we're done. And I can now check the history of my dataset to, for example, find out what has changed between the current state and the previously saved change by just doing a diff between the state now and the state one version back. And you can see that all of these additional files, for example, the functional files for subject 2, have been added and saved into my dataset. Importantly, this has all been recorded with this quite cryptic looking command, but this is executable, actionable provenance that would allow me to use the information that is kept in this machine readable format here about container, about input data, about output data, and then just rerun it with what is called a Datalet rerun command. Now, the last thing that I want to show you after I quickly summarize reproducible execution, I'm just going to run over this. So the Datalet run command is able to record a command and its impact on a dataset. You can specify inputs with an input flag and things will be retrieved. You can also supply outputs in the form of individual files, data directories, complete files, which will make recomputation possible. And you can use Datalet containers run to extend the execution and re-execution capabilities also to software containers with either Docker or Singularity containers. And rerun is going to be in the code, but I'm not sure whether I can get there in this in the remaining minutes. But you could just do a datalad rerun of this commit hash to completely recompute everything that was done here and verify that the outputs are identical to what has been produced before. But what I really want to show you here, because I think it is nice to know, is how to publish data with Datalet datasets, because this is also something that Datalet makes quite easy. Datalet is built to maximize interoperability. And whatever storage or hosting infrastructure you're using, Datalet can probably interface with it. So if you're using G Drive or GitLab or Amazon Web Services, then Datalet can be a connecting layer through these services. And typically, we have these different parts that are involved in a data publishing routine. You can have repository hosting services that can expose your data set to a wider audience. You can have third-party storage providers that actually take care of managing the large data and hosting it. And you have your workstations or server where you have your data set. And the question is, how do you get this published? And I'm going to show you how, with a simple example, which is using the Gin repository hosting service, which is a free service that you can use to publish data. I'm going to quickly run you through this, and you can redo this at home whenever you have time. So first, I'm going to sign into my account here. And one thing that I will do, the first thing that I will do if I wouldn't have a user account already is that I would need to upload an SSH key. I have included tutorials on how to do this in the handbook, but I've done this already, so I can continue just with creating a new repository. And I'm going to call it bitsdata2 because I already have bitsdata. And this is basically it. I can share, select a license for my data. And once I've created a new repository, I can get such a URL to it. And this is a URL that I can then make known to my dataset as a location to where to publish data to. And this is what I'm adding here. I'm adding a so-called sibling, which is a clone, a linked copy of this data set. I'm calling it Gin, and I'm pointing it to the repository that I have just created. Importantly, I'm using an SSH URL, like that. And what I have done now is I have a DataLad sibling that is called Gin, and I can use that to push all of the data, the just nicely converted bits data, to this repository on Gin, and it will push my Git history with the re-executable provenance about my data transformation to Gin, and it will also push all of the data that is inside of this data set for others to clone and use and reuse. So to just give you a screenshot-based rundown, I have logged into Gin, I have uploaded my SSH key, I've created a new repository and added the Gin repository into my dataset. And finally, I have pushed all of my data. And once this command, it's taking a little bit because it's pushing a bunch of data to Gin, I have a nicely populated repository that contains all of the data that I wanted to share. And I can point my collaborators or the public or my friends to it so that they can DataLad clone this repository and retrieve data for themselves, for their analysis, and so forth. Now, I would show you DataLad rerun if my terminal wouldn't be occupied by this pushing that is in progress. But all of the things that are remaining in my codecast that I wanted to execute are in the script that I pointed you to in the DataLad handbook. So the remaining pieces of this tutorial are all nicely explained in this introduction here. What I would have shown you is how to clone the dataset from Gin after it has been published, by cloning it from its HTTPS URL. You can do this even if you don't have a user account on Gin. It supports anonymous HTTPS access. If it's a public repository, if you're publishing your own data, you will need to make sure to make your repository public because they are by default private. And I would have used this input data set to perform another containerized computation to just extract the brain mask from this data. This would have included the Datalet download URL command, which would retrieve web content, in this case, a script that I've pushed to GitHub, and save it with the origin or the location, the web location of this file registered into the dataset. And I would have added another container, this time not from the containers repronym collection, but from Docker Hub or from Singularity Hub, depending on which software solution you would use. And then run the second Datalet containers run command to retrieve or to compute the brain masks from the data that I have just created. And with this, I would have, if I had the time, gotten through a full data analysis from raw data to actual brain imaging results. But if you're interested in that, then you can all redo this or do this on your own computers with the commands that I have pasted here. The containers and the data, that they are all public so that you can actually execute these commands, but you can also redo this with your own copies, create a new container, push it to Docker Hub, for example, and just replace the commands that I've shown here. So in order to not run over time, I'm going to stop sharing now. And if you have any questions, then I'd be happy to answer them. If not, then I want to thank you for your attention and apologize for running a little bit over time.
Thank you so much, Adina. I can verify that if you do have the time, you can run through all the commands that are in that document. That was part of my test yesterday. So cutting and pasting from that is great. So in your spare time, it's a fun exercise, and it really adds reality to sometimes, this version control is kind of nebulous until you really see it work with your container, with your data, with public data, and the ability to publish and to process it just covers everything. It's a great demonstration. Thank you.